So we have the notes here for Chapter 1, Section 3. You should have a paper in front of you now. The paper that you have has all the names of these properties, and you will be able to use this paper for the quiz on Friday. Okay, so you don't have to memorize all of these. You're going to have that paper right in front of you. Our goal is going to be that you see something and then you identify which property is being demonstrated there. So again, you do not have to memorize these. You have to be able to see a property and match it to its name using the paper that you've been given. So first I would put your name on that paper, and then we'll go through. So the reflexive property, you can see that here. It basically just says that something equals itself. You'll see the same thing on both sides of the equals sign, exactly the same thing, and in the same order. The symmetric property says that you can flip things over the equals sign and it still means the same thing. Again, you've used these properties before. You just didn't even really realize that's what you were doing, or the names of why, kind of the math laws of why you're allowed to do this. So 8 equals 2 plus 6 is the same as saying 2 plus 6 equals 8. So the symmetric property says you can switch what's on the left and right of an equals sign, and it still means the same thing. In the transitive property, we have that two things equal the same thing. Do you see how both 6 plus 9 equals 3 plus 12 and 3 plus 12 equals 15? So it's kind of this logical progression. You can see it here too, if that makes more sense. If A equals B and B equals C, well then A must equal C. So again, you're going to see a repeat in the if part, and they're going to conclude that the first part is equal to the last part. That's the transitive property. Substitution, again, you've used this before. Substitution just says that if two things are equal, you can replace one with the other. Just like when you substitute in a game or when you have a substitute teacher come in, one comes out and the other equal part comes in. I know it's a little hard with this here, but you can read it on your paper as well. So substitution is I pulled one thing out and replaced it with another. So they pulled out the n and replaced it with an 11 because those two are equal. Additive inverse and additive identity can be a little confusing. The key to it is the inverse, you're looking for it to equal 0. It says when I add the positive and the negative version of the same number, it equals 0. One undoes the other. So additive inverse, you're looking for it to equal 0. In additive identity, they are adding 0. So it's not equaling 0. The 0 appears, but it's being added with something else. Same thing down here. You just have to kind of watch where things are. Multiplicative identity just says, listen, if I multiply something by 1, it equals itself. That's what additive identity was. If I add 0 to something, it equals itself. I'm not really changing it. So the identities are saying you can do something, either add or multiply, and by something, and you will see it equals itself. Multiplicative property of 0 just says anything multiplied by 0 equals 0. So again, you're going to look for it equaling 0. You're going to see multiply over here versus equaling 0 up here. It's in adding. Multiplicative inverse, again, I'm not quite sure how to get this off right now. You're going to see it equal to 1. So the inverse and the identity look very similar. The inverse is saying, what do I need to multiply to get back to 1? So you're going to see it equal 1, where in the identity it was multiplied by 1. And again, you're going to have this paper, and we'll talk through some examples as well. Commutative property just says that with multiplication and addition, you can move things around and get the same thing. If you add 4 and 8, that's the same thing as adding 8 and 4. If you multiply 7 by 11, it's the same thing as multiplying 11 by 7. So in commutative property, you're looking for them not to switch over the equals sign, but kind of switch the order of what they're adding or multiplying, but they're still the same numbers. In the associative property, associate means to group. If you associate with a group then of friends, you're grouping together. So what you'll see here is you'll see the same order on the left and right side, but parentheses will move. So if you look from here to here, I still have a 3, a 5, a 7, a 3, a 5, a 7, but on the left side I group 3 and 5, and on the right side I group 5 and 7. The associative property just says when you're multiplying or adding, you can group different numbers and it won't change your final answer. If I add 3 and 5 first, then add 7, it's the same as adding 5 and 7 first and adding 3. And with multiplication and addition, that's possible. You're going to see a movement of parentheses here, grouping a different 2 on the right than it did on the left. So have that paper out right next to you, and I'm going to talk you through. You are welcome to push pause on a video and write down your own answers. We've talked about before, your brain grows more when you struggle. So if you would write down your guesses and try to use your paper to match this to a property and then turn it back on, yeah, you may get some wrong, but your brain will grow and you will learn it deeper than just listening to me and copying answers. So I would recommend trying to pause now. All right, for the first one, I see 2, 8, 5, 7, 2, 5, 8, 7. So I see it's the same numbers, but they switched the 8 and the 5. So I'm going to look for a property that says, listen, it's okay in multiplication to switch the order. If you turn your paper over, you will see that is the commutative property. Again, it says that you can switch multiplication or addition, and it's still the same answer. In letter B, 5, 3x, 5, 3x. So the order didn't change, but on the left side, I've grouped the 3 and the x, and on the right side, I grouped the 5 and the 3. So notice the order didn't change, but what I grouped together in parentheses, what I associated. So this one is the associative property. In this one, I see they're almost the same thing on the left and the right, but this has a times 1 on this side. So if you flip back to the front of your page and look for a property where they're multiplying by 1 and it equals itself. Okay, so look through and down toward the bottom, you should see that is the multiplicative identity. Okay, so again, you can pause at any time if you're like, wait, what did she say? Push pause and go look at your paper. In letter D, I have multiplication and I have a 1 again, but this time it's equaling 1. I'm multiplying to get back to the identity. So this is multiplicative inverse. If you go look at that, it's down at the bottom of the front page, and that is when you multiply 2 things to get 1. In letter E, I'm multiplying. Okay, that's going to give me an idea I should look at multiplication properties, and I'm multiplying by 0 equals 0. And that will match up to multiplicative property of 0. Okay, we have a few more here. So 3x equals 3x. I see it's just saying the same thing equals itself. So if you look up at the top of your paper, you will see this one. It's in there. Again, what I would suggest at this point is that you push pause, try these for yourself, and then come back. If you get them wrong, oh well. Again, your brain is growing more than just listening to me and copying the answers. You're not really going to understand it. If you try these, even if you get every single one wrong, your brain will be growing. You'll understand it better. So please push pause now and try these with your group or by yourself. All right, this one, something equals itself. If you look at the top of the paper, that's reflexive. Over here, I see adding, so that's going to lead me to addition properties. I'm adding 0. When I add 0 to something, I get itself. And if you see that, you can match that up with additive identity. In letter H, 4x equals 20, then 20 equals 4x. So here I move things. I move them over the equal sign. So this is different than commutative property because I moved 4x from the left side of the equals to the right side of the equals. And you will find that up top in the symmetric property. Over here, if x equals 3, then 5x equals 5 times 3. So they took the 5x, and over here they took the x out and replaced it with the 3. So they said, x, you come out, you go sit on the bench, 3's coming in. Substitution for that one. And again, if you're not sure, pause, look at the example I gave you, and look at the property on your paper, see if you can match up what happened. In letter J, I see adding. Okay, so that might give me a little bit of a clue. I'm going to look at addition, and it's equaling 0. So which property says when you add the opposites, it equals 0? And that would be additive inverse. The last one down here, if A equals B and B equals 7, then A equals 7. You see that repeat here in the if, that it repeated B twice? It basically kind of took it out in the end. The answer to this one, which I didn't type in for some reason, is transitive. Transitive. It's on the front page in Properties of Equality, so this is the transitive. Okay, so now you're going to go try and practice some of these.